Ratio control is used to maintain a fixed proportion between two or more variables. Today's video is going to focus on this aspect of process control. Now, this could include any type of ratio of your choice. Let's keep it nice and simple. Imagine that you want to make a product which is mixed up with two or made up of two different products that come in, possibly liquid A and liquid B. And the first thing that comes to mind is maybe we'd like to make some chocolate. What we would do is we would bring the first product in and take it into our mixing tank. And then we're going to bring the second product in. But remember, the second product needs to be controlled. And so I'm going to be putting a control valve onto the whole process line itself. Let's go and say that the first product is possibly going to be some milk, and the second product could be cocoa liquid or anything of your choice. Now, the heart of a ratio control is going to be the actual controller itself. So let's go and draw that in. And I'm just going to label it as a fractional flow controller. You would call it whatever your policies would dictate in the working organization. We need to measure the two flows. And so I'm going to be putting a flow transmitter onto the milk, and I will be taking that signal into my ratio controller. I also need to put a flow transmitter onto the liquid cocoa and take that into the ratio controller as well. Now, this is where you'd have to come in with your settings. You can go put in any ratio of your choice, such as a 1:1 or a 1:2 or a 3:1 or a 5:1, anything that you need to. And this controller will then go and control the final control element so that you and I can receive the ratio that we would like to go and get. And that's it. Now, there are two important definitions that I would like to go and put in. The flow at the top is going to be known as the wild flow, because that can change as the process allows it to change. We don't worry about that as long as we know what it is doing. The flow at the bottom is going to be known as the controlled flow. We will look at the changes in the wild flow, and we will make sure that we maintain that ratio in our controlled flow. I will be doing a video on this shortly, but just to let you know that as far as the ratio control is concerned, that is going to be an open loop type of control. We're going to mix the two liquids together, and we're going to assume that the results are correct. We're not going to be putting in some or other type of analyzer to check that out. Yes, there is a little bit of closed loop or feedback control, and that's going to sit in that area at the bottom, because we're going to measure the flow in order to control the flow. So that small little piece will be closed loop, but the overall loop is going to be an open loop. I'm going to start off with the whole process being in manual, and I'd like you to focus on the control valve at the bottom. What we're going to do is the controller is in manual, and I'm going to open or close that valve. And all that you will see is that as I open the valve, there's a greater amount of flow that's going to go through it. And as I close the valve, there's going to be a smaller amount of flow that's going to go through it. The controller is in manual, and we are going to, I've just gone and changed it with a flow range of 0 to 100%. Remember, we're looking at the cocoa flow, which is going to be my controlled flow. Now, if I was to take the valve and change the output from 35% to 45%, the red pen is going to represent my process variable, which is the flow of the cocoa. And as you can see, as the output increases, that flow is going to increase. If I was to take that to 55%, we're going to have a greater amount of flow that's going to go through it. And maybe we can just take it back down to 35%. So as we open and close the valve manually, so we're going to increase or reduce the amount of flow that's going to go through it. My next step is going to be to put that controller into automatic, and we're going to focus on this area at the bottom. We're not in full ratio control yet, but we are just going to take that controller and put it into auto. Now this means that the controller is going to operate according to a set point. So let's go and put that controller into automatic and run the process. And I will now go and change the set point, and you can see that the process variable will make its way up to the new set point. And wherever I take the set point, that is where the process variable is going to move to. The red pen is a representation of the process variable, and the blue pen is going to be the output from the controller itself. We are now going to do the full ratio control. If you look at my graph, you are going to just be able to see a gray pen where the mouse pointer is. That is my wild flow. In other words, that is going to be the flow of the milk that goes through the controller. Now, I have got a ratio that has been set in as a 1-to-1 ratio. And hopefully when I go and switch on the ratio control, this red line of mine is going to be controlled to be the same as the gray line. So let's go and switch on the ratio control. And you can actually see that the red pen has now moved up to the gray line. So if I was to drop my wild flow, which is the milk, down to about 50%, you're going to see that the red pen, which is the controlled flow, and the cocoa liquid is going to follow it. And wherever I go and move the gray pen to, you can see that the red pen is going to follow it. So we've got a nice even 1-to-1 ratio that we can go and utilize. Now, there's nothing stopping you from changing the ratio. I'm going to go to the ratio button, and let's go and put in a ratio of 0.5, which now means that the red pen is going to be half of the white pen. The white pen is now at this point in time, let's go and see if we can pick that up. I'm going to move it, increase it. The white pen is going to go up to 40, and the white pen has gone up to 60, and you can see that the gray pen is at 30. Let's go and take the white pen up to 80%, and you can see that the red pen is down to 40%. So wherever you'd like to move it, it's going to maintain that ratio for us. I'm now down to 50% on the white pen, and you can see that the red pen is down to 250. Maybe one more thing is, just to make this more realistic, I'm going to go and put in a ratio of 1-to-1, and let's auto load the process, which would represent what would happen out in the field. And now you can see that as the gray pen moves up and down, so my ratio is going to force the red pen, my controlled flow, to follow it as closely as possible. And that literally is going to be a good example of ratio control.